Okay, Specialist Mathematics, Paper 2, Tech Active from 2023. This is the short answer. I'm going to do question 11. Question 11. The bounded region between the graphs of the functions over a certain domain is shaded as shown. The two functions intersect at the origin and point A. Determine the coordinates of point A. All right. I am going to, as my first thing, I'm going to go to my graph. I am checking, because I am trig, I'm going to check that I am in radian mode. Cool. My first graph is -1 plus sec is 1 over cos, so I'm just going to go 1 over cos in brackets x over 5, close my brackets. Then I'm going to go 0.1 x squared. Oops, I've got x squared, didn't hit for. Draw. Okay. Shift, G-solve, intersect. Zero, zero. And we look for another point, which is not within my window. Let's change my view window. Let's make that to 20. Draw. Oh, there we go. That looks more like my graph, doesn't it? I can see my shaded area now. So shift, G-solve, intersect. Okay, it gives me 0, 0. Go across. Oh, there we go. And it gives, look at that, it gives me that the coordinates are 7, 4.9. Okay. Now it asks for the calculate the area of the shaded region. So again, we can do that graphically. We don't need to jump back out of here. G-solve. I'm going to go across to the integral sign. And we're going to go intersect. So from there to there, execute, there it is. Now calculate the area of the shaded region. It's giving me a negative 6.14. We want our area to be positive, so we're just going to go 6.14 units squared. Oh, the integral, they worked out. Anyway, 6.14. You can see here where it says area 6.14. Now it said the shaded region is rotated about the x-axis to form a solid of revolution. To determine the volume of the solid of revolution. All right, so back to the rule sheet. Around the x-axis, as they want it. So v equals pi, a to b, fy. Fx squared. So it's this one here. All right, so we go back here, we look at this. It's going to be graphing around the x-axis. Now looking at, so this is going to be going this way. We need to do the functions taking away. It's going to be from 0 to 7, isn't it? Yeah, that's where our limits are. Which curve takes away which curve? If you look at it on the graph here, the red take away the blue. So exit out, the red is the 0.1x squared. So if you're unsure which is which, okay, so we can see when we draw it, the red take the blue. So I'm going to have 0.1x squared take -1 plus sec x on 4 squared dx. I need to enter that in my calculator, so I'm going to go back to my run mat mode. I can do it all in one hit. Shift pi. I want an integral, so that's options calc integral. Brackets 0.1x squared close bracket squared, take away in brackets -1 plus, I always do this with sec, I always put 1 on the top, and then it's going to be cos in brackets x over 5, close those brackets, close those brackets, squared, between 0 and 7. Oh, syntax error. What have I done? Oh, I messed up my bracket, didn't I? So delete that, and then I've just got to take it big. There we go, I got my brackets right now. There we go, and we get our volume is 69.76 units squared. Is it? No, units cubed. We're a volume, aren't we? This is a volume. So there we go. That was question 11. Kind of nice. Lots of calculator work on that. Take care.